All right, welcome back to the deep dive. If you've ever thought about, moving into the cloud world, or maybe you're just prepping for that first big certification exam, you definitely know the feeling.
Oh, yeah.
It's that moment. The sheer volume of new vocabulary just hits you. It's not even the advanced architecture that gets people. It's that initial alphabet soup.
It absolutely is. I mean, that foundational level, like the AWS Cloud Practitioner exam, it requires you to master hundreds of acronyms. You come in wanting to learn quickly, but you just end up feeling completely submerged in jargon. It's exhausting. It's just this massive information overload.
That's the challenge. And the source material we pulled for this deep dive
Yeah.
is a rapid review that's designed for exactly this problem. It really cuts through the noise and forces you to focus on comparisons.
Right.
So our mission today is a true shortcut. We're going to extract the essential nuances between these pairs of terms that sound almost identical but have, fundamentally different use cases. Because AWS just loves those comparison questions.
They do. They really do. They want to know that you understand the context of the tools. If you can define why you'd use S3 instead of EBS, or, when you choose a security group over an NACL, you skip right past the simple definitions and get to that well-informed moment. We're focusing purely on that crucial dividing line.
Okay, so let's unpack this.
Yeah.
We should start at the very beginning with the business argument. Because every journey to the cloud starts with a spreadsheet, right? We have to talk about how you pay for it. The comparison here is Capex versus Opex. What's the core difference that, drives this entire cloud migration industry?
Well, what's so fascinating here is that this comparison, it provides the entire economic justification for the cloud. We are talking about Capex, or capital expenditure, versus Opex, operational expenditure.
Right.
And Capex is, well, it's the old school data center model. It is the necessity of making these massive upfront investments for physical assets.
So buying the building, the actual servers, the racks, the heavy-duty HVAC systems, all of that. It's a huge purchase order before you even turn anything on.
Exactly. It's paid for before you even know if you need like 10% of those resources or 100%. It's a sunk cost.
Yeah.
And that severely impacts your cash flow because the assets immediately begin to depreciate and you're locked in for years. You're trying to forecast capacity based on your best guess of what you'll need in 3 to 5 years, and you usually overbuy.
Just to be safe.
Just to be safe, yeah. And the problem with overbuying is that it just sits there as idle resources, and that's wasted money locked up in cooling and maintenance and everything else.
Precisely.
So that's the heavy burden of Capex. Now, Opex, the operational expenditure model, is what AWS really pioneered. It just flips the script entirely.
Okay.
You pay for what you use when you use it. You consume resources like electricity or water. It's an operational cost that only shows up when you actually use it.
That drastically improves cash flow. Suddenly, a startup can access global infrastructure without needing a massive venture capital round just to buy hardware.
It democratizes access, exactly. And the key financial difference is that flexibility. If you need 100 servers on Tuesday for a spike in traffic and then 0 servers on Wednesday, you only pay for those 100 server hours.
An elasticity that's just impossible in the Capex model.
Impossible.
So if the cloud is supposedly cheaper, how do you actually justify that to a CFO who's just seeing these monthly billing statements going up? That brings us to the metric TCO.
TCO, total cost of ownership. This is the argument. This is what justifies the move. And it's so crucial to understand TCO because it accounts for all the things we forget about when we only look at the cost of the server hardware itself.
So tell me more about those hidden costs. What are we talking about outside of, the obvious physical server rack?
We're talking about the things that cause real stress for IT departments. Think about the physical security. Do you need guards to watch the building? The power consumption, you're paying massive industrial electricity bills. The cooling, maintaining a super narrow temperature range for servers requires complex, expensive HVAC. And critically, the specialized staff required to maintain and patch all of that infrastructure 24/7.
I hadn't even thought about the human capital side of TCO. So when I moved to AWS, I'm not just renting a virtual server. I'm offloading the stress of keeping the lights on, the AC running, and the OS patched up to the hypervisor level.
You are. You're trading Capex, a high-stress, locked-in capital investment, for Opex, which is a flexible pay-as-you-go cost, and you're lowering your TCO because AWS absorbs all those hidden infrastructure costs.
That's why we start here. Cost is the foundation.
It really is.
That settles the money side. So once you figured out how you're paying for the system, the next logical question is who gets to access it and how. Let's transition into security and identity, focusing on IAM users versus IAM roles.
Okay, this is a classic point of confusion because they both sound like an identity, but their purpose is totally different, and that's the key nuance. Think of an IAM user as your permanent badge.
Okay, the permanent badge. So that's me, the developer, logging in every morning.
Correct. It is tied to a specific person. It requires a username and a password, and the credentials are long-term. They don't just automatically expire. That user identity represents an entity that's permanently interacting with the platform.
That makes perfect sense for a person. But if we already have these specific permanent users, why do we even need IAM roles?
Because an IAM role is fundamentally different. It's designed for temporary access. I love the hat analogy here.
Okay.
A role is a defined set of permissions that a user or a machine, it sort of puts on the hat briefly to gain a certain set of powers and then immediately takes it off.
The temporary hat. So what happens when you put the hat on?
Crucially, when you assume a role, you get temporary security credentials, a short-lived key and secret. It never, ever has a permanent password associated with it. This is the defining security feature.
That no password detail is critical, especially when we think about, machine-to-service communication. Why can't a service, like an EC2 instance, just have an IAM user identity? Wouldn't it be easier?
It would be easier, but terribly insecure. If your EC2 instance had long-term user credentials hard-coded into it, and a bad actor compromised that instance, well, they would have permanent keys to your kingdom. Roles solve this. They are primarily used for machines, like an EC2 instance needing to securely read logs from an S3 bucket or talk to a database, or for users who are federating in from their corporate identity system.
Hold on. Let's quickly define federating in for someone new to this. That sounds like logging in through a third party.
It is, yeah. It just means your company uses an existing identity provider like Azure AD or Okta. When you log in there, AWS trusts that provider and grants you temporary access by having you assume a specific IAM role.
So AWS doesn't even store your permanent corporate password.
Exactly. The role is the bridge that lets someone operate without AWS managing their permanent personal credentials. It significantly improves your security posture because you're limiting the number of long-term targets.
Okay, so when you are studying or preparing for that architecture review, remember the hot tip. If the scenario involves temporary access, service-to-service communication, or federated login, the answer is
Overwhelmingly an IAM role. Permanent access for a person. IAM user.
That's a huge insight nugget. Roles equal temporary, secure access. Now let's tackle the classic firewall battle security groups versus NACLs, or network access control lists. This is probably the most frequently mixed up pair. They confuse people because, well, they both handle traffic. What is the fundamental golden rule that differentiates them?
The golden rule is based on state and where they live. So security groups, or SGs, are stateful, and they operate at the instance level.
Okay, stateful. Let's really drill down into that. What does being smart or stateful actually mean for traffic flow?
It means the security group remembers the connection. If you define an inbound rule, say you allow SSH traffic on port 22, the security group immediately opens the reciprocal outbound path. The response traffic is automatically allowed back out.
So you only need one rule for a two-way conversation.
Only one rule. It remembers the state of the connection.
It's the smart bouncer standing right at the server door. He looks at your ID on the way in, and if you're in, he doesn't need to check you again on the way out.
Perfect analogy. That's the instance level. It protects one server, or maybe a small group of them. Now, the NACL is the opposite. NACLs are stateless.
Stateless, which you said means dumb. I like that term because it illustrates the complexity.
They are dumb in the sense that they don't remember the connection state. So if you write a rule to allow inbound traffic, you must write a separate, explicit rule to allow the corresponding outbound traffic.
So for every single conversation, you have to write two rules.
Two rules, one in, one out.
That sounds incredibly tedious. So if security groups are smart and they're at the instance level, why on earth do we even need the complexity of stateless NACLs?
Yeah.
Wouldn't it be easier if everything was stateful?
It would, but you'd lose a really critical layer of defense. NACLs operate at the subnet level. They are the perimeter fence around an entire block of resources before the traffic can even get to the bouncer, the security group.
I see. It's the first line of defense.
It is. The NACL provides that coarse-grained, network-wide control.
So if I accidentally misconfigure a security group, I've exposed one server. But if I misconfigure the NACL, I've exposed the entire subnet, all my database, web, and app servers inside that network block.
Exactly. That massive difference in scope is why you need both. And here's another key difference for now. NACLs process traffic based on rule numbers, from lowest to highest. If Rule 100 allows traffic and Rule 200 denies it, Rule 100 wins.
And security groups.
Security groups evaluate all rules and take the most permissive action. They don't use ordered rules.
Okay, the fact that NACLs are numbered and ordered, and stateful versus stateless, that defines their role as the network perimeter. The bouncer, the security group, is smart and server-specific. The perimeter fence, the NACL, is ordered, dumb, and subnet-wide.
That's it. That clarifies the necessary complexity.
Perfect. Let's finish with a crucial architectural decision. The storage comparison. We need to know the fundamental difference between S3 and EBS. The rapid review simplifies this down to just 2 words: object versus block.
That is the core distinction, and it dictates everything about the use case. S3, or simple storage service, is object storage.
When you say object storage, what does that mean in practical terms for the listener?
Think of object storage as being for discrete, flat files, your photos, videos, log files, massive backups, data lakes, static website assets, just blobs of data.
Okay.
S3 accesses these blobs using a unique key, like a URL, and it's accessible over the internet via HTTP. It's infinitely scalable and incredibly durable.
So it's basically my massive, globally accessible digital attic where I can just dump everything.
Precisely. But here's the critical limitation. Because it's accessed over a web API and the data is stored as these flat objects, you absolutely cannot install an operating system on S3. An OS needs low-latency, organized file addressing. S3 can't provide that.
So S3 is great for static websites or dumping petabytes of data, but not for an OS. What about EBS then? What kind of data structure does it provide?
EBS, or Elastic Block Store, provides block storage. And block storage emulates a conventional physical hard drive, a disk volume. This gives you the low-latency, organized addressing that an operating system needs. You do install an operating system on EBS. It functions as the C drive, or the root volume for your server.
So EBS is that necessary high-speed local storage layer required for things like databases, transactional applications, or running heavy software on a virtual machine.
Yes, exactly. And the key requirement for EBS is that it must be attached to a specific server, an EC2 instance, to function. It doesn't just exist independently. It provides the volume that the server needs to boot up and run.
Knowing the difference between object storage, S3 HTTP access, flat files, no OS, and block storage, EBS OS compatible, requires an EC2 attachment, fast, that defines the entire application choice.
It does.
You don't want your backup logs sitting on expensive EBS, and you absolutely can't run your database off S3.
And what really stands out here is that every single one of these comparison pairs requires you to move past the superficial definition. You have to understand the application and the architecture.
Right.
Do you need temporary access or a permanent login? Is the mechanism stateful or stateless? Is the data a flat file or a bootable volume? Answering those application questions is how you gain real knowledge.
So what does this all mean? We just distilled 4 huge, easily confused concepts that really form the backbone of the AWS foundation: Capex versus Opex, users versus roles, SGS versus NACLs, and S3 versus EBS, reaffirming that breaking down these nuanced terms makes the entire cloud foundation far less intimidating.
Absolutely. The confusion just dissolves when you use this comparative structure. You're not just memorizing disparate definitions, you're learning the essential dividing line between them. It's a much more efficient and effective way to gain that knowledge quickly.
And we encourage you to use this structure, temporary versus permanent, object versus block, stateful versus stateless, when you're tackling other cloud vocabulary. If you can define why they are different, not just what they are, you're well-informed and ready for anything.
And if we connect this to the bigger picture, once this fundamental vocabulary clicks, you can immediately start thinking about those bigger, more strategic architectural choices.
That raises an important question for further exploration. Once you master these terms, the core logic starts to click into place. For instance, the source material also mentions the distinction between a region and an availability zone. So your next step, as you're learning, should be to explore how those geographic definitions connect directly to your disaster recovery strategy. Think about how choosing between deploying across multiple availability zones versus multiple regions actually changes your tolerance for failure.
And that leads right into the core problem of scaling. You'll quickly see the implications of these vocabulary choices when you start to investigate the differences between horizontal scaling, so adding more small servers, and vertical scaling, which is making one server bigger. That strategic decision is the next frontier once you master the building blocks we covered today.
Excellent food for thought. We'll see you on the next deep dive.